Yeah. Good morning, everyone. We will start in a minute. We'll start in just a minute. Mm. Vijay, can you try to share? I just want to make sure you have correct permissions.
Um, you mean the slides?
Yeah, you can
Yeah.
share anything, not necessarily the slides. You can
How about
share.
now?
Oh, yes. Okay. Okay. Good. We can see. Yeah,
All right.
and you can, if you want to leave them up, that's good. We are going to start in a few seconds.
Sure, just give me a sec.
Okay, good morning, everyone. It's the last Friday of the month, and here we are with our eighth. And this is our eighth webinar. We started in January. And thank you so much for being here. We have Vijay. Vijay is the assistant professor in the ECE department at NC State. He's also the director of NextG Wireless Lab and AERPAW Outreach Director. And also, Vijay co-founded two things, and that is Wings, the Winsight Lab and All Things Intelligence Inc. And also, Vijay, I know you wrote a book, Foundations of Oran, right? I think I saw that at some point. So if you want to go learn more about Oran, Vijay has a book that is called Fundamentals of Oran. And today you're going to talk to us about ORAN and operations. First of all, from your lab, I know you have done a lot with ORAN in your own labs, but also how you're going to extend those to airport operations. And we look forward to hear from you. And with that, I want to say, if you have a question, I believe you can see a chat or Q&A. I will ask Suhani, can you see Q&A? In your chat, yes, because you're Suhani,
Yes,
actually Suhani is our
yeah.
outreach coordinator. So is there you have Q and you can see Q&A, right?
Yes, I can see
Okay.
the Q&A.
Yes. So please feel free to send your questions there and we will be monitoring that. And Vijay, is up to you if you want to take the questions in between. We'll monitor the chat and Q&A for you. And we can stop if you want. We can tell you that if there's questions so you can respond to it, or you can take questions all the way until the end once you finish presenting. That's your choice. But with that, I want to welcome everybody to our webinar and welcome Vijay. The floor is
Yeah.
yours.
All right. Do you see my presentation slide, the full slide?
Yes, I can see it.
Wonderful. Okay, thanks
Yes.
for having me. I think we should probably keep the questions to the last, given that it's Q&A, right? All right. So I guess I don't need to introduce myself here, but I'm a faculty at NC State University with the EC department. So here is how I'm gonna organize my talk today, right? So here is a quick outline just to give you an idea, right? This Open RAN or ORAN is something that happened in MWC 2018, right? That's when it was founded. So what was before Open RAN, right? And what is happening today, right? After several years since Open RAN concept was born, right? So, and obviously, given that this is an AirPower seminar, I also want to briefly talk about how AirPower is going to support Open RAN and the upcoming AI RAN, right? So that's how I have organized the slide. Hopefully, it will make sense. So let's start with pre-ORAN or pre-Open RAN discussion very briefly. Okay. So just to sort of set the stage, I do not know what kind of wireless background you have, whether you are familiar with cellular wireless system or not. So just wanted to give a little bit of background so that we are all on the same page when I talk about Open RAN and the research in that domain and beyond, right? So just starting with the RAN, I guess before I talk about RAN, it's very important to understand what is RAN, right? So generally any cellular system, right? Whether it's a 2G or a 3G or a 4G or 5G and potentially the future generations, they all can be categorized as three big components: the RAN, the core, and the users. Okay. So the idea is that the user is any device that connects to the cellular system, like your smartphone, your fridge, your laptop, your smartwatch, and whatnot, right? So anything that connects to the cellular system or cellular network, we call them UV, which stands for user equipment. Okay. And then we have the core, which is basically the entity that provides you access to the larger internet, right? Eventually, right, most of the time you are using your device to access the internet, right? So core is the entity which actually connects your cellular devices to the internet. So that's a big functionality of core. And obviously the operator who is providing you the cellular service like Verizon and T-Mobile, they want to charge you, they want to make sure that you are connected all the time. So core also maintains all the user database, all the user information, make sure that you're actually a subscriber of that particular operator. And then when you travel from let's say Raleigh to DC, you are still connected when you go through multiple cities and places, right? So the core is not just providing access to the internet, but also making sure or managing everything about the user information so that they can bill you, they can ensure that you have the connectivity, and it also manages the mobility, right? And mobility is a big reason why cellular services are so widespread, right? Otherwise, we have Wi-Fi and other services, but they are not that widespread. Uh, and then in the middle, we have these little devices similar to a Wi-Fi access point, which actually connects your device to the cellular network, right? And in totality, we call them radio access network. Okay. So our talk is focused on radio access network. So let's just start with the very first generation of radio access network. So there, the idea was that you have these base station or a cell site where if you still see, I think there are still many cell site where it's kind of protected through this wires, right? And then in the middle there is a big tower like something like this, right? And then there is a little box, relatively large steel box, which is co-located at the cell site. So basically each cell site would look something like that, right? So now that cell site is connected to the core through literally a wired network. So even though it's a wireless network, the only wireless that exists is actually at the edge, which is from the user to the base station. That's it. Everything else is still wired. Okay. So that's how it looked like, but that's not what is important. The important piece is that it used to be completely proprietary. So you basically go to one of the three big vendors like Nokia, Ericsson, Samsung, right? And then you literally purchase them and you deploy them and you operate them, right? That's the job of Verizon, right? They do not build any devices. They simply purchase it from one of the big RAN vendor, and then they deploy it, and then they manage it, they operate it, they have the license to do it, right? It's completely monolithic. It's a complete one big system. So you cannot really change this, let's say this tower and buy another one. You cannot do that. If this comes from Nokia, this also has to come from Nokia. This also has to come from Nokia, right? And it's not flexible because these are all big boxes, so you cannot really change, let's say, some functionality. Let's say you have this amazing transformer-based scheduler, right? You cannot do that. You have to literally go and replace a Nokia hardware which has the new algorithm and then put it back, right? So that's how it looked like. So that was really painful for the operators to upgrade, and that is probably the reason why we only see cellular upgrade every tens of years, right? Because it's such a huge capital expenditure industry in many ways. Then people said, okay, we can do better, right? So that's where the concept of cloudified RAN or a virtualized RAN came in. Here, the beauty was that instead of having this big entity, which is still a server, right? Instead of having it at each and every cell site, we actually put it somewhere at the regional server. It stands for baseband unit, so it does all the processing, right? Somewhere at the regional. And the idea was that if you reduce the number of BBUs, then you are reducing the amount of cost involved. And also it's still useful because you might still be able to meet all the requirements of these users that are connected to these devices through some optimization, right? Then we said, okay, why have it at a dedicated server? Why not have it on a cloud? And that's where the virtualized RAN concept came in, right? And it also virtualized the core. Here it was still a data server or some kind of physical server hosting the core functionality. Now you don't need to get that. You can literally serve it on a cloud, right? So it actually helped, right? So now it is still proprietary. You still cannot get a core from Nokia and connect it to a Samsung RAN. It still has to come from the same vendor. But at least the beauty was that this virtualization, softwareization, it changed the game, right? Now your RAN functionalities are completely software microservices or software applications, right? So if you want to update it, it's possible. Okay. So that sort of laid the foundation of Open RAN. Okay. So what Open RAN did, it completely borrowed the idea of softwareization and virtualization from the previous generation of RAN, which is the cloudified RAN and virtualized RAN. And we took it even further. We said, okay, can we make our interfaces, can we make our softwares, right, can we make our servers open, right? It means that now you can get, let's say, the RAN from a vendor X and core from vendor Y. And even within RAN, we further disaggregated the RAN into something called radio unit, distributed unit, and centralized unit, and put it at different places. So this is the radio unit. So this is in many ways RRH plus some low physical layer. Now, I'm not gonna get into the details of disaggregation, but the intuition was that we don't want highly time critical physical layer functionality at a very distant server because it's not gonna work because of the latency issues mostly. And also there is a um, huge capacity cost on the front haul. Okay, so because of those reasons, the ORAN decided, or the ORAN Alliance decided, that we'll keep some of the physical layer at the cell side so that it has little pressure on the front haul, which is the interface between the DU and the RU. And then it also helps with the latency criticality aspects. And the DU is a sort of BBU minus the low physical layer. Okay. And the centralized unit is the less critical, time critical, I mean, the less time critical functionality like PDCP and the RRC, which is hosted somewhere even further away because the latency is not a problem. And then on top of that, we say, we actually want a very what do you say, abstraction layer, like a middleware, for example, like an operating system, which can actually control or has interfaces to all the RAN component, obviously all the softwareized RAN component like the DU and the CU. And then this software layer or the middle layer, you can literally develop applications on top of this, and then this application developer doesn't really need to know how to get data from the RAN, how to control or send control aspects to the RAN. So in many ways, this is like an operating system in a computer. So if you recall computer, right, we can build application on top of a computer, like a browser application or a WhatsApp application. You can install it, you can run it, but the application developer doesn't need to worry how that browser application is going to access the internet, or is going to access the RAM, or is going to access the hard disk, right? It doesn't need to worry about all that. The operating system makes sure that you get what you want, right? So in many ways, this RIC, the RAN intelligent controller, is the RAN operating system, okay? Which sort of abstract the entire RAN hardware and gives you exactly what you need for the application to run, okay? So that's the idea of Open RAN. So it obviously added a lot more flexibility. It added intelligence. So in many ways, the Open RAN was founded on two principles: the openness because of the interfaces between these different components, and intelligence because of the AI integration into the RAN. So here is the very high level idea. So the Open RAN mission, again in 2018, these different operators from the world, right? AT&T from US, China Mobile from China, and so on. They came together and they said, we want an intelligent open RAN. This virtualized RAN was already there. And obviously the interoperable, right? This is where the value of mix and match between different component is important, right? Otherwise, your RAN will not work if they don't interoperate, right? Um, and then this is what I discussed earlier, right? The RAN intelligent controller is in many ways the RAN operating system that abstracts the entire radio access network so that you can implement amazing applications without worrying how it will work with the RAN, the RAN hardware. When I say RAN hardware, I mean the antennas, the radio front end, the scheduler, the PDCP, all those different layers. As of today, you cannot really control the RU because it's still completely hardware. But except RU, you can control anything you like. So now, depending upon the time granularity, right? It's a real system. So depending on that, we actually divided the RIC into two components. The non-real-time RIC, which basically means any functionality that is okay to run in more than a second. For example, frequency assignment or network slicing, right? Or policy management, right? Those things do not change every second, right? So for those things, you can literally run it, somewhere very, very remote where the latency is not a problem. So those are on the non-real-time rig. And the applications, we call it RAP or the remote applications. And you see why it's called remote application, right? Then we have another one called near real-time rig. These are the latency critical applications. And we call it XApp or extended application because you are extending the RAN functionality and deploying it as an application or a software microservice on the rig platform. Okay, so this is still more than 10 milliseconds. So you cannot really run a scheduler here, but you can run some other, like, I don't know, power control, RB allocation, positioning, sensing, spectrum sensing stuff. Many different applications. I'll talk about a few XApp later. And then very recently, people are talking about this real-time rig, where the idea is that we will have this layer sitting literally on the side of a DU. Okay, so it means now you can run application every millisecond or even less than a millisecond, right? So this is not fully standardized yet. This is still being discussed within ORAN Alliance under research item 2 under NGRG. NGRG is the next generation research group, working group. And here there are two terms people are using in the field. One is called distributed application or DApp, proposed by Northeastern folks, which is actually pretty popular at this point. So I think the Oran Alliance is going to adopt DApp. But a year before Northeastern proposed DApp, UC San Diego guys, they proposed micro app or mu app. And the term they use for real time rig is called edge rig. It's slightly different. The architecture is slightly different. I'm not going to get into that yet. But as of today, it seems like DApp is probably going to be standardized, where they will not have a separate rig. They will simply have these applications directly running within the DU and have this standardized interface called E3. Okay, so it's kind of an extension of E2. All right, so if that makes sense, so this is the class I teach every fall. So this is too late for you guys now, but if next year I still teach, you can consider taking if you want to learn more. So now let me talk about ORAN, right? So I already covered the pre-ORAN at a very, very high level. I hope it sort of positions what is Open RAN trying to do in the RAN industry, right? And then when we started this work, I started Open RAN research back in late 2019, so just a year after it was founded. So at the time, there was a lot of interest in applications, okay, at least in the academic community, right? In the industry community, they were mostly interested about this disaggregated RAN, that can I get an RU from vendor X and DU from vendor Y and CU from vendor Z so that it can be much cheaper and also higher. So, for example, some company has better DU compared to some other company who may have better RU. So, sort of best in class equipment at potentially cheaper price, right? Um, So in the industry, RAP was actually more entertained. Ericsson has this thing called EIAP, which basically allows the community to come in, contribute the RAP, test them, and if they like it, they can potentially even adopt into their system. Okay, but in academia, or this is the data here, right? If you see that this RAP is so like in 2024 there is literally no XApp, and in 2027 we are hoping that we'll still focus on RAP, and I see why, because RAP is a much slower application, right? You are doing it every more than a second, but you're potentially doing it every hour or every 24 hour or maybe every week. So if something goes wrong, you have time to fix it, right? XApp is very critical, right? It runs in tens of milliseconds to a second. So if something goes wrong, you don't really have time to fix it, right? So they are being very careful in deploying the new technology so that they don't hamper the network rather than getting benefit from that, right? And in academia, it was mostly, I would say, near real time break, right? There was a lot of papers in early 2022, 2023, even 2024, right? There were a lot of papers on XApp, right? And then since 2023, 2024, people have started looking into DApp, right? So we focus more on science. We focus more on more challenging problem. Business likes certainty, right? Business like let's say reliable solutions, right? So that's why they are more focused on our app. We are more focused on XApp and DApp, right? And actually in XApp and DApp there is a lot more researchy work rather than our app. Our app is more boring, like policy management and those kind of stuff. So now within this XApp and RApp, let me briefly talk about what AirPow can enable, right? So I guess you all are familiar with AirPow at this point, right? So we have this outdoor test bed about 7 square kilometer, like 2.8 into 2.4, as you can see here, right? And we have another site, one square kilometer, which is an urban site on the Centennial campus, right? And our main use case is the unmanned vehicles, particularly the aerial vehicles. So we have been looking at how to integrate Open RAN into AirPower. So here is some high level idea how Open RAN can help the main use case of AirPower, which is UAV. So as you can see here, UAV has very unique challenges compared to the general UEs, the smartphones, right? Our mobility is very different. There will be a lot of frequent handovers, unlike a walking person with a phone, right? Our KPI could be varying a lot because the UAV flies. It sees multiple cells. There are huge interference issue there. So the ORAN can actually help solve a lot of this problem, right? We can have this near real-time break intelligence every tens of milliseconds. So irrespective of how dynamic you are or how rapid you are changing, you might be able to cope with it, right? So here is one example, like we can do XApp for UAV optimization. So here is one little example here, right? So we have this near real-time break, we have this UAV as a UE, and then basically this base station is being controlled through this near real-time break. You can look at the KPI telemetry collected through the O1 interface or some interface in Open RAN, and then you can actually send this mobility control to the UAV. So now within the sample experiment that you can see in AirPow, these are the OAI. The OAI is the open source cellular software. So we have a couple of experiments there. But let me talk more about the example I just discussed. So in here, this is a implementation that's going on by a PhD student, Sarif, who I co-advise with Dr. Ismail. So here is the scenario. So we want to do UAV mobility and policy management through an X app, and the intuition is that there is a OAI Gnode B running on OAI software, and it's basically we collect the KPIs, and then this is the database that what do you say, stores the KPIs before the XApp can act on it, and then it basically sends, let's say, the what do you say, the waypoint or the mobility to the UAV controller. See, because the RAN doesn't have a mechanism to control the UAV. It's the UAV controller, right? So what you can do, you can send from XApp to the UAV controller, and there is an interface called Y1, right? So Y1 allows the near real-time rig to communicate or interface with an external server. Okay, so in this case, that's a UAV controller, right? And then you can basically do the UAV mobility. So here is a little demo on how we did it in the digital twin. So right now it's being developed under not under within the AirPower digital twin. So here is a little snapshot of how the rig is working. Okay, so here as you can see, we are collecting these KPIs. So like for example, all these RLC, PDCP, right, MAC, and E2SM is the E2 service model that, and this RC is the radio control that allows you to send the control messages from the near real-time rig to the base station. And then, so here are different metrics like PDCP and then throughput, downlink, uplink, PRB, downlink, uplink, RSRP, SINR, right, PSCS, and so on. So you can collect as much metric as possible as long as those metrics are coming from the DU and CU. You cannot collect metrics from RU yet, okay, unless you somehow hack into the management plane. So this is the what you said gnode b log, which shows that it has a stable connection. And here are some plot how these things are changing. So before, I mean, these are probably not very useful. Let me show you a little demo of how this works. So here is the demo of how this works. So on the top, right, this slide deck here is showing how the UAV. So this, if you look at this UAV, this UAV is traveling from Gnode B1 to Gnode B2. So at the beginning, it is connected to Gnode B1, and as it travels far away from the Gnode B1, it gets connected to Gnode B2, and then back, right? So this is the capability we already have in the AirPower Digital Twin. It's still under testing. The student was out for internship at AT&T Labs, so he's back now. Now that the semester has started, so hopefully it will be tested very quickly and be made available to you folks, right? So that you can continue with the research and experimentation and so on. Okay, so it's pretty slow, but hopefully you'll see. So it's just showing different logs, Gnode B1, Gnode B2. This is the user, which is actually the UAV. And then at some point, as it travels far away, you'll see a handover trigger, and then that's the experiment basically. So this basically demonstrate the real-time UAV UE mobility, which supports handover across multiple base stations. Yeah, I will just, yeah, see. So if you see now, so the UAV is, traveling from here to here. So at some point you'll see that it changes the base station. Okay. All right. So now that we are, give me a second. Looks like,
It's here issue with the slides.
yeah, it's not the updated one.
Okay,
Yeah,
maybe
it
we
has
can
most of
find
the
it.
slides. That's all right.
Yeah, meanwhile, please send your questions. If you have any question right now, you can send it in the QA. If you don't see the Q&A, you can also even send in the chat if you see the chat. We'll be taking your questions at the end.
Yeah, just a second. This is weird.
Yeah, let me know as you are doing that. I can actually. I know some of you have used AERPAW. You let me know when you are ready, Vijay, but meanwhile, I can share my screen and show quickly.
That's okay, I guess.
You
I guess I'll
got it?
just, yeah, I mean, yeah, I did not receive it, but I'll continue with this slide. It's 90% same.
Okay, because I just wanted to show the user
Sure.
manual
Sure.
from where, I wanted to show the user manual quick from where you were pulling the experiment. But for those people who have not used AERPAW before, if you go to our website and there's user manual right here, there is a lot. If you go down the sample experiment repository here, you can find all the sample experiment, including the one that Vijay was showing you. And even all of these are different categories we have for the experiment, and you can see OAI experiment under 6.12. You can check those ones. I just wanted to pull that to show people where they can find those experiments.
All right. Thank you. Okay,
You're
I'll continue
welcome,
with the
sure.
same slide. It's fine.
Okay,
Okay.
so
So actually, there were a couple of slides where I was showing this about 6-8 XApp that we have built within Nexi Lab. That includes jamming detection and classification XApp, published in Milcom 2023. Then there was a Spark XApp RApp, which was basically a collaboration between interference. Um, what do you say? Interference classification XApp and resource block scheduling DApp, and how they work together to give better network within a smart warehouse like environment. And then there was another one on ODSS XApp, which was basically a couple of XApp. One was anomaly detection XApp. So what it did, it basically detects whether some whether you see that there is some anomaly in the environment, right? That anomaly could be a radar, could be something else. And once you have an anomaly, which is just based on KPIs, now you further analyze whether that anomaly was because of the radar or something else, right? And if there was a radar, then where exactly in bandwidth you those resource blocks you can coexist, right? So there were a few XApp that I wanted to talk about, but that's fine. All right, so now let's see what happened to Open RAN, right? So as I mentioned, Open RAN had a lot of excitement, right? At least in early 2020s, right? And then obviously the market was also very excited, right? The guys like Mavenir, right? They spent so much money on building RU, right? Billions of dollars, if I'm not wrong, right? And then there were smaller players, new players like AirHop and Cirrus 360, Remedo, right? There were a lot of RU vendors like Benetel, Betel, Lions, Light On, and there's so many, right? And then there were quite a bit of story about milestones in deployment. Like Japan had this amazing Rakuten deployments across millions of cells, field trial deployment in Africa somewhere, right? We had this wireless trying to become the first fully ORAN native um, operator, the fourth operator in the country, right? But in 2024, or let's say a couple of years ago, the reality hit, right? The reality was that there was no money. Okay. So obviously there was a lot of promise, right? All these disaggregation, softwareization, intelligence, right? But the biggest problem was that there was no clear clarity on how to make money because of the open RAN, right? So because if you're asking an operator to go capital expenditure and you're not telling me the additional revenue it's going to bring, then why am I going to do it? Right? So that was a big problem. Then obviously the vendor was very, very hesitant, right? Because it's not a tested technology, right? It's a promising technology, but it's not tested yet fully. So for example, I'll give you a very concrete example, right? AT&T signed a $14 billion contract with Ericsson to upgrade their network to an ORAN compliant 5G network. But but interesting to see that they actually went with one vendor, right? That the whole idea about Open RAN was to go with multiple vendor, right? But they actually went with one vendor to deploy an ORAN compliant 5G, right? And I honestly I see why. Because if something goes in the network, you can go to Ericsson and say, go fix it, right? But if you buy, let's say, the antennas and radios from Avenir, you buy DU and CU from Ericsson, and if something goes wrong, right, who is gonna fix it? Right? You cannot say Ericsson. Ericsson will say that my DU is great. There must be something wrong with RU. If you go to RU, they will say, my RU is great. There must be something wrong with your DU, right? So who is gonna take the blame, right? So that was a big problem, and that sort of highlights the third problem, which is the interoperability crisis, right? There was no one entity who you can fully trust that that if something goes wrong, that guy is gonna fix it. Okay, again, in with a single vendor, you literally buy everything from the same vendor, the RU, DU, CU, right? So if something goes wrong, you can point to that guy that go fix it, right? But in ORAN, there wasn't anything like that. Obviously, we try to fix it through the establishment of this TNE center, the testing and integration center, as a part of NTIA effort, or through OTIC, right, or ORAN testing and integration center. But they were not matured enough, right, to sort of take that job yet, right? And it took months, right, to do this interoperability testing from multiple vendors. It takes many, many weeks and many, many months. So it slows down the entire upgradation process. And you know how competitive this market is, right? You want to be the first vendor, sorry, first operator who brings 5G to the world, or the first operator who brings 6G to the world, right? So you don't really want to slow down for marketing purposes, right? So these all created a lot of issue in the widespread adoption of Open RAN at a very large scale. Okay, so it hasn't completely died, but it has definitely slowed down. Okay, so in 2024, something else happened, right? In 2024 Mobile World Congress, we said, AI RAN, right? Nokia came with this amazing before I get there, let me briefly explain what AI RAN Alliance is trying to do, right? So AI RAN Alliance is sort of, as of today, they are positioning these three big use cases, right? The one is AI for RAN, which is the typical ORAN functionality in many ways, right? That you want to enhance the existing RAN functionalities further with the introduction of AI, right? So Open RAN in many ways tried to do that, right? You remember Open RAN tried to bring intelligence. One of the principles was intelligence. So Open RAN was obviously more about architecture, but it also brought intelligence, right? So in many ways, I think AI Open RAN already did AI for RAN. Obviously, Open RAN did not have DApp. So, but AI for RAN doesn't care whether it's a DApp or an XApp. They don't even use the terminology as such. They simply call it applications, right? But these two are new. So AI on RAN, the intuition is that why are we limited to making money out of our subscribers only by providing this connectivity or this communications to those guys, right? Can we not make money out of something more, right? So that's where the idea of AI on RAN came. That can we enable these newer applications like robotics and sensing and object detection, and for them, they are gonna rely on our data, the RAN data, and we're gonna make money out of it. Okay. So that is in many ways the physical AI concept that people are talking about today, right? And telecom actually is very well positioned for this, right? Because telecom is the only entity in the entire world which has one hub connectivity to each and every user, each and every device in the country, right? I mean, Wi-Fi is there too, but Wi-Fi is not reliable, right? So this is the idea, which I think is a great idea. And then there is AI and RAN, right? So there is a big, compute need for all these AI world today, right? And as of today, we are always going with the data centers. Right? We're trying to create more and more data centers, which is becoming a problem, right? And also, you can create data centers, but data center cannot guarantee you milliseconds and tens of milliseconds of latency, which is critical if you go beyond a chat GPT interaction, right? Or a chat interaction, right? For a chat interaction, a second delay is probably not something you care about. But if you want, let's say, some amazing functionality to be automated through AI agent, in that case, the 1 millisecond latency is a huge latency, right? Sorry, 1 second latency is a huge latency, right? So the idea is that can we run some of the AI workload on the RAN compute itself? And the beauty is that the RAN compute is actually very available when there is no traffic, especially in the night, or when there is very little traffic, right? So the idea is because we already have all this compute deployed for supporting RAN functionality, can we not use idle compute to support AI inference model or even training in that case potentially to make more money? Okay. So now we are not just acting as a connectivity fabric, but we are actually acting as a data center. We are actually acting as an edge application hosting entity, right? So we are trying to make more money. Okay. So if this happens, then obviously it's gonna help the telecom industry. So this actually took the central stage because of the Nvidia Nokia announcement that happened, right? That Nvidia invested this couple of billion or 1 billion, I don't remember, into Nokia, and the idea was that we will put this Nvidia GPU on the Nokia base stations, right? So in many ways, we are trying to create these very mini data centers, right? And then enable this physical AI application. And the intuition was that we will make more money, right? By performing these age analytics application or run this amazing AI model, right? So again, and this makes sense to me, right? That for any technology to really succeed, industry has to see profit, right? Otherwise industry will never bet into it, right? It's not the welfare scheme going on here, right? So yeah, so that's what happened. The discussion changed from Open RAN to AI RAN because there is a clarity of revenue here. Okay. So one of the question I'm asking and potentially others are asking is that can AI RAN or should AI RAN converge with Open RAN, right? I think the answer is probably all of them. Okay. Why? Because Open RAN does enable this amazing standardized open interfaces, which allows you to collect this telemetry, which actually can support AI application. And then those AI application can actually help control the RAN function, improve the RAN itself. And you can use the same telemetry to do those age analytics so that you can make more money, right? And it also brings the cost down and everything down, right? So I think OpenAI RAN is actually an amazing architecture that can realize a fully AI native future of connectivity, right? Obviously, if you don't want competition, then you can follow the Apple route, right? Where you do everything on your own, right? So you can still have AI RAN, you can still have access to all those telemetry, but it's all proprietary, right? So it's up to you, right? Whether you want to follow a Windows or an Apple route, or do you want to follow a Linux route, right? So it's all up there, right? It all depends on the business case that you're trying to follow. Okay, and then this is an amazing thing that happened last year, right? Okudu. So Okudu is this initiative from Department of War Future G office, and then they are basically saying that we are going to build commercial grade CU and DU software that is completely open source. Okay, so if this succeed, I am seeing or I am hoping that a lot of a small company will actually build 5G network, which will be fully ORAN compliant because of the CU and DU, and basically enable private 5G or enable community scale cellular networks, and that will change the equation quite a bit, I think. So I'm hoping that Okudi would succeed. So let's see. And looks like the government is really interested in Open RAN, and I see why uh, because uh, because when this commercial entity, right, they they innovate at a much faster rate, right? The 4Gs and 5Gs happen, almost every decade. And then obviously they invest a lot of money, right? Because there is a commercial aspect to it. So, but the defense, right? They have their own requirement, right? They also want to use 5G for many good reasons, but then they have a huge security requirement. They have other things that's going on. So now when they ask the commercial guys to do it for them, then it becomes a problem, right? But if it is fully open source, right, like Open RAN, then they can actually customize the 5G network to their needs without relying on the commercial operators, right? So for those reasons, I think they are very interested, and they're trying to push they're trying to help Open RAN succeed. Okay. And another angle is probably US, right? That none of our cellular vendors today are US based, right? They are Ericsson coming from Europe, Samsung coming from South Korea, and Nokia again coming from Europe, right? So and then there is a Chinese one which we don't even allow to deploy, right? So given that, right, US really wants a presence, a US presence in this market, because this telecom is a huge infrastructure, a critical infrastructure, right? So I think that probably is another reason. So now if you look at the AI RAN research, right, where is people looking at, right? So the first one, because of NVIDIA, Nokia stuff, they are trying to really sell GPUs, right? And then they are trying to position that this hi-fi, they are hugely computationally expensive entities. So you can use our NVIDIA Aerial to do that, which is a GPU-based acceleration. And not just that, you can use the remaining GPU to support AI workload, and you can make more money, right? So this is where NVIDIA came in, and that's why there is a huge interest in NVIDIA Aerial platform. And I think that is probably their understanding that I'm going to give you $1 billion, you must deploy our NVIDIA Aerial with the RU. I think they went with AirSpan, if I'm not wrong. NVIDIA Aerial with AirSpan RU, and with obviously the Nokia, what do you say, Nokia core and so on, right? So that's, I think, what they're trying to do. Obviously, Ericsson is not fully on board. They're like, oh, this is way too expensive in terms of the cost. Like one NVIDIA GPU might cost you hundreds of thousands of dollars. And also the energy consumption is huge. And honestly, there isn't really any AI vendor today who is willing to pay you to host their workload, right? So they are still going with this AI 4 RAN route, and they're simply trying to make the ASIC or the compute based system more efficient to support AI, right? So they keep publishing this new result that we improve the spectrum efficiency by 20%, and by 2027 or 2030 we'll make it 100% by using AI, right? And that's why we are AI native, right? But they are limited to AI 4 RAN use case. And again, ASICs are much cheaper, right? Which also makes sense. So again, there is potentially a divergence there. So anyway, but that's an interest. Another one is LLM, right? It's all over the place, right? So automation, obviously, within telecom, we are trying to look at how LLMs or foundational model can help us. So there is a big effort going on called Large Telecom Model, led by GSMA, SoftBank, and stuff. We also did some work like ORAN site, which was potentially the first foundational model designed for Open RAN. And then there is this, even the LLM is sort of going towards agentic AI, right? Where the AI agents will talk to each other directly without a human in the loop, using this MCP protocol, right? And the idea is to make everything autonomous, faster, simpler. But obviously there is a huge token cost involved and so on. So people are still looking into all that, right? So that's where we are going. I'm gonna skip this slide. So this is one recent work that we did, I think last year or so, and this is in many way trying to address the interoperability issues, right? Remember I mentioned that this RU, CU, RIC, right? They are all different components, and it takes several weeks and months to interoperate them, to make sure or to test them extensively, to make sure that they actually work in the field, right? So this was becoming a huge problem. So we developed something called AI 5G test, and we automated the whole testing process, and we were able to show that we are able to do that in less than 3 minutes, right? But this is just the automation piece from test case to telling whether the test case has passed or failed. And if it fails, then we are able to tell why it fails, right? So we are kind of uh, um, our scope is limited to that. So now we are trying to extend it further. That can we create new test cases automatically? Can we close the loop? That once you find the failure, can you go fix it? Right. So we are looking into those things. This is the ORAN side that I talked about, right? This was the first domain-specific ORAN models that outperformed or beat all the other models in the field at the time, and it was actually acknowledged by ORAN Alliance that this is the best ORAN LLM at that point, right? Maybe 3 years ago. We also have benchmarkings, right? We have developed and made it available like ORAN bench, SRS RAN bench, which is actually adopted by the GSMA AI initiative. It's called Telco Open Telco Initiative. So if you see ORAN bench and SRS RAN bench, these are contributed by my group, and there are 5 others. We also recently developed tele-resilience bench, and we also made Okudu bench available, which is also called tele software engineering bench. So the idea was that these are all MCQ questions, right? That can LLM reason about the specifications or the features. But we recently created this bench, which help LLM generate new telecom. Okay, so this is old slide, right? Like I said, so I have updated all this in the newer slide. But anyway, we recently had this paper from with Samsung. Welcome to the live. Where we created this universal agent where it can forecast any KPI across any cell for the Samsung. So this was with Samsung. We had about 7 KPIs, 200 cells somewhere in Dallas, US. And then we are able to forecast it, and we are able to further tell if there is some anomaly that's going to happen and how to fix it, right? This is published in Globecom now. And then we also extended this work to multi-agentic framework where you can actually have agent who reads the logs, another agent, who consumes the incoming logs and take an action, let's say resource block control and whatnot. And we actually had to build a tele MCP protocol, which extended the naive MCP. And as you can see here, the value was that we use much less tokens than a naive MCP that was released by Anthropic at the time, right? Um, this is a tool that we developed. It's called Neural Smith, and the idea was that our telecom people, right? We understand our data, but we are not AI experts, right? So we build this tool called Neural Smith, who actually takes your input. Let's say you have this amazing data, and let's say you have a spectrograms, for example, right? And you're trying to detect whether there is a radar or there is a jammer in the environment or not, right? So you basically tell them in plain English, and then Neural Smith actually builds a model in few minutes that works for that data set. So I'm going to skip all this, and we also evaluated on multiple data sets from our literature. And as you can see, we are at par, potentially better than what was reported in those papers. But that's not the biggest value. The biggest value is the time. So if you see, Neural Smith is able to build these models in few minutes and seconds. This is another work where we sort of automated the entire ORAN pipeline. So let me show you how. So if you're familiar with Open RAN, right, at this point, so in Open RAN, what happens? You have the RAN here, and you basically collect the data through O1 interface. It goes into the non-real-time rig. You store it in some database, let's say, and then you use that data and then basically give it to some kind of ML training pipeline, right? Like for example, clear ML, let's say, right? And then this clear ML basically do whatever you want to do. You train it, and then you give it back to the near real time brick. And then once the model is trained, you give it to the near real time brick where you deploy it as an XR, for example, right? And then it basically controls the RAN, right? So this is usually what happens as of today in Open RAN. So we automated this whole thing. We said, like for example, when the data comes here, how do you know that this data is for a certain scenario? How do you label it, right? And then how do you know what kind of XApp you're gonna build? And then this ML, this clear ML, it doesn't do it automatically. You still have to work in the clear ML to make it to do the data processing and then choose a better good model, do the hyperparameter tuning, and then basically have a trained model which actually does well, right? So for that, what we did, we
Sorry,
created this
sorry, sorry,
two brain
Vijay.
approach or a dual brain approach, where the
Hello,
idea was
Vijay.
that we have a zero touch orchestration agent, which is an LLM. So what it does, it basically takes an intent. So here it basically takes an intent from the operator, whatever you are trying to do. And once you give the intent, the agent itself curates the data and labels the data. Okay. And once it labels, then it gives the data to the neural smith, and neural smith does the entire ML process, like feature engineering, model creation, selection, generation. It trains the model, it makes sure that it gives the accuracy you want. And once the model is trained, it gives a platform independent ONNX model, and that is given back to the non-real time rig, and it packages that model as an XApp and deploys it. So that's the overall process here. If you want to try it out, it's available, it's free, and it's available as a CLI in the both agentic mode and the user mode. It's a very simple, just pip install Neural Smith CLI. Or if you use a lot of today's tools like Cursor and Claude, you can actually have it as a skill, just a couple lines of code here to install it. Or if you are, let's say, more visual person, it's also available as a extension in the Visual Studio Code. But this is not very stable, I would say, at this point. The CLI and the skill are pretty stable, so you should be able to use it. So with that, I'll thank my group and then I'll conclude here. So AI native connectivity is sort of already happening with Open RAN, AI RAN, right? And AERPAW is already testing ORAN capability, and our obviously the goal will be to test AI RAN and will be made available very quickly. ORAN will be made available much quickly um, in the digital twin before AI RAN. Okay. And then obviously, these are some of the tools that I briefly talked about. And just a concluding remark here, right? Software is eating the world. It's not something I said, but I extended it. That AI is eating the software and software is eating the world. So AI is eating the world. Okay. So with that, I'll take some questions.
Thank you so much, Vijay, and I hope the software is not going
Oh,
to eat
you are
us.
muted.
Can you hear me now?
You are muted, Magnet. I cannot. Oh, sorry.
Really?
Oh,
I'm
sorry. My
not.
bad. My bad. Looks like, yeah, I
Okay.
can hear you.
Can you hear me now?
Yeah.
Okay, that's good. I was saying I hope the software don't eat us as well. But yes, thank you so much,
Robotics
Vijay.
will.
That's a lot of information, and it's exciting to be a researcher at this time. I know we're running out of time, and I have three questions, and I had my question. I hope I get to mine at the end, but we have 3 minutes and three questions. The first one is that there is no interface between RIC and the RIU because ORAN doesn't specify it, or because OAI doesn't implement it, or
Oh, no.
something else.
No, ORAN
What do you think?
Alliance doesn't have an interface with RU. The only interface we have is the front hall or the CUSM plane, it's called. Uh, Control plane, user plane, synchronization plane, and management plane. So out of which three planes, the control plane, user plane, and synchronization plane is between the DU and the RU. And then management plane is all the way to the management, the SMO, right? So that you can do fault, it's like you have to keep track of RU, right? How good the RU is. If RU is faulty or RU is behaving weird or something is wrong, you have to know. So that's the management plane. But there is no interface that allows you to collect data beyond the open front hall. Okay, and there is no way you can control the RU because RU is completely hardware. Okay.
Okay, yeah, thank you so much. The second one is saying, which LTE software framework are you using?
Which LTE?
Which LTE software framework are
So
you
in our
using?
lab, we use Okudu, which is basically a successor of SRS RAN. So in the past, we use SRS LTE like a few years ago. Then we moved to SRS 5G, and then recently, a few months ago, we moved to Okudu. So right now we have Okudu. So the Okudu will be supported on AirPower Digital Twin. We also have OAI for some of our positioning and sensing work, but we are prioritizing Okudu in AirPower Digital Twin. Yeah, but in my lab we have both.
Okay, and the third one is, what are free data sets for getting metrics of run instead of deploying the end-to-end system so we can experiment with ZT agent you introduced?
So there are tractor data set, right, from UT Austin, Cosix Group, right? We also release some of our data set. You can find it on Nexi Wireless Lab. We have ODSS data set, the radar, and we have the interference data set. What are the other data set? You should look at RF Data Factory. Oh, actually, okay, this is not
Okay.
complete yet. Okay, let me show you something. So actually, my group right now is building this amazing tool, which I'm kind of announcing here, but it's not complete.
Yeah,
So
it's
we are
it's a
building,
launch, a pre-launch.
so we are building this open wireless learning platform where you can find any wireless data set. So right now we have about 1,000 data set. Not just that, okay? We are actually making sure that we replicate all the machine learning solution that has been proposed with that data set on that paper. Okay, so that we want to see how much of them are reproducible. So listen, these are all the data set you see. Okay, and then if they are not reproducible, okay, so these are all the papers that they cite, right, those data set, and we reproduce in a proper way, where you can find the methodology. Here is the methodology. Okay, so we sort of tell the community that, see, this is what we did. And this is fully agentic. Okay, we are not doing it manually. So this is what we did. This is the results we are getting, which may or may not be on par with the paper reported values. And the reason is, the paper misses out a lot of information. They don't give us their seed information. They don't give us, many a times there is split information, right? So for those reasons, we have to make some assumptions. So we do that, and then we say, okay, given this is the best accuracy F1 score, blah blah, that's there. If you think this is wrong, or if you have a better machine learning model, give it to us or upload it on our website and we'll report it. So we are trying to create a platform where you have a reproducible machine learning models that you can rely on, you can use, in your solution, right? So again, it's not available yet, but that's what we're trying to do, because we found that there is no way today to sort of reproduce existing wireless machine learning research. Okay, so hopefully in a
Okay.
couple of weeks, or maybe at least it won't take us more than, I would say, a month, because we are trying to demonstrate it at upcoming Okudu and other places. So hopefully it will be available very soon. So you should be able to download dataset here and even download the models. Yeah. Yeah, but
Yeah,
RF
thank
Data
you.
Factory is a good repository to look at.
Okay. Thank you
Yeah,
so much, Vijay, for all that information. And we are going to close with this one. I know you're hosting OAI workshop in October 13th to 14th, right?
that's right.
And probably a lot of OAI, or like ORAN, AI run 4 in and end, they're all going to happen there. Do you want to talk a little, just 1 minute? We are over time for 3 minutes.
Yeah.
So just want to
So
conclude with that workshop and let's get out of here.
sure, sure. So OAI workshop at this point this year has two themes. One is AI native networks, and the second one is ISAC. Okay, so it's completely student driven. Out of 2 days, it's 1.5 day of student training and hackathon. So it's a great opportunity for you to actually use AI and then develop these amazing AI applications and ISAC applications. So there would be hackathon as well. So you'll basically partner with a team of 5 students, and you literally develop solutions right there. It's fully hands-on. So yeah, I think it's a great opportunity for the students to learn.
Brilliant. Okay, thank you so much, and thank you for everyone for being here. We will see you again on. We are going to do the next webinar September 25th. And thank you so much, and bye. Have a wonderful weekend. Bye.
Thank you for having me. Bye bye.
Thank you. Yeah, you're welcome. Thank you. Bye bye. And I know someone asked if we can have the recording. Yes, we have the recording in our YouTube. We have a YouTube channel. Actually, I can post it right here for those who you are still here. I can post the YouTube channel that we have all the webinars are recorded. And give me a minute. I will send you the link. Oh, also one if you have a link right next to you. Okay, no, it's here. Okay, so if you were waiting for the link for our webinar, it's right here. This is the entire playlist. And this one will also be posted soon. So thank you, everyone.